All right, so we're going to be talking about the money multiplier now, which is similar to the GDP multiplier, but slightly different. But both work under the same mathematic principle. Mathematical, whatever. But the money multiplier is the idea that the Federal Reserve can expand the supply of money by a significant amount through their monetary policy actions. And most notably, the reserve ratio is actually going to give us the multiplier. And so what it'll do is it'll expand the supply of money, which lowers interest rates and raises GDP. Oh, sorry. That raises GDP. All right. So it works like this. First, probably a review of this. M1, cash and checkable deposits, and those are fully liquid. M2, savings, mutual funds, all that stuff. M3, long-term time deposits. What's not part of the money supply is any money at the Federal Reserve. That's important to keep in mind too. All right, so once again, we're doing a balance sheet. All right, so we'll just reserves. We'll call it 50. We will call the demand deposits 500. We will say that there are securities in the amount of 450. So we balance. Cool. All right. Now, this money, it's a checkable deposit. It's part of the money supply. Got it? Good. All right. So let's say that let's say that Nicole has we'll say $1,000. Okay, so that's Nick has $1,000, and she goes, that's part of the money supply because again, it's cash. So it's part of the money supply. So whatever. Nick deposits the $1,000 into this bank. So now the demand deposits become $1,500. The bank gets $1,000 in reserves. So this becomes $1,050. Okay? All right. The money supply has not changed. We have shifted some money from cash into checkable deposits, or at the worst into savings, but it hasn't changed the money supply at all. So there have been no effect on nominal interest rates so far. However, if this bank has a 10% reserve ratio, okay, they, of this $1,500, can loan out as much as they have to keep 150. So they could loan out 1,350 total. Okay, because 10% of 1,500 is 150. So that's how much they have to keep. Before Nicole deposited this money, they had $500 and $50. They were at their reserve requirement. So it might be easier for you to just consider that because they were at their capacity before, they're just going to loan out 90% of this. However you want to do it is entirely up to you. But when you math this all out, either way you do it, they are going to loan out $900. So they loaned $900, and then this becomes a $150. And it's a good idea to occasionally just check and make sure you still balance. 450 and 150, 600 plus 900 is 1,500, 1,500. Good. Outstanding. All right. So there we go. That loan goes out to someone. In fact, you know what? Let's do this better. Let's do this better. And we'll use this right now. Go away, blue. All right. Assets, liabilities. Okay. So, reserves, we'll just say 100. Demand deposits, 1,000. Bonds 900. All right. So they get another, let's say, well, you know what? We'll just do $100. Somebody deposits $100. So this becomes 1,100. Okay. And this becomes 200. All right. Cool. All right. Boop, boop. Okay. So here's what happens. When somebody comes in for a loan, the first thing that happens is actually, because I see the reason why I'm doing this is I actually skipped a step here, and it's important that I show you. It's the kind of the hazard of doing this so much. Okay, so let's say that somebody comes in and wants a loan. They're like I said before, they're going to create a loan, and they'll be able to create a loan for, let's say, 110. If the reserve rate is 10% here, we'll just call it 10%. If the reserve rate is 10% of this 1,100, they have to keep 110. They have 200, so they can loan out 90. So we're going to create a loan of 90. The thing is, and this is kind of the important part, initially, that $90 loan they create doesn't come out of reserves, because what they're first doing, think about the bank. Okay, so I'm sitting on $200 of money, and somebody asks for a loan. I'm not actually going to give them that money. I'm going to create a checking account in their name, or a demand deposit account, and put that $90 in there. So we have this additional account of $90. And they can then go off and do whatever they want with that money. They can, well, I mean, I'm assuming as a bank, if I'm giving them the money, I know what they're doing with that money. But that's kind of beside the point. Anyway, so that's actually what's initially going on. Notice that this $90 is owned by both this person and this person simultaneously. And the bank effectively has created $90 of new money. Because look, there originally was $1,100 here, $1,100 here. Now there's $1,190. And this is part of the money supply. It's spendable. So I've created $90 of new money, and it's going to turn into more, because when that person goes out and spends that money, then this goes away and this becomes 110. That doesn't mean the money disappeared. Somebody out there has that money now. It's in somebody's hands. It's not in the bank. That is money that didn't exist before that is now in someone's hands. What are they going to do with it sooner or later? Deposit it. So they deposit that $90. Okay? And then this goes to 200 again. But they can't loan out 90 again. They can loan out 10% of this, which is 1,190. So 1,190 is their total demand deposits. So their required would be $119 of that 119. So they can loan out $81. So that they're going to create another $81 loan. And anytime you want, you can consolidate these, just add it together. I'm just going to keep this separate for now, but it's all one loan category. All right, so now we have DD of 81. I've now expanded the money supply by an additional $81. Okay, next, that money gets spent. Then this goes to 119. And guess what's going to happen? It's going to wind up in the bank. It may not be this bank. It may not be this bank, but it doesn't really matter. And it's actually probably easier if you just consider this balance sheet to kind of be what's called a consolidated sheet of the banking system. So instead of a bank, this is a balance sheet of all the banks in the banking system. But, you know, this 81 gets deposited permanently. This becomes 200 again. Let's see, 1190 plus 81 is 1271. So they have to keep 127.1 $127.10, which means they can loan out $72.90, and then this becomes $72.90. You know, you get the idea. It's going to keep going and going and going, and each time that happens, that's creating money. So the question is, how much money is going to be created? If this looks familiar, and it should, it's the same thing we did with $1 when we did the GDP multiplier. Spend $1, which becomes 91 cents, which becomes 82, and so on and so forth. Did I math that right? It doesn't matter. Anyway, so we knew that if the MPS was 0.1, then the multiplier is 10. So this dollar would become $10 of GDP change. The same is true of money supply. So if we have a loan for, how much was our initial loan? $90. The formula for the money multiplier, I'll move my hand in a second, is 1 over reserve rate, which is 10%. So 1 over 10% is a money multiplier of 10. So the initial loan, and then the way you apply that is its initial loan. You know what? I'll make it easier for you. It is initial loan, but change in money supply times multiplier equals total change. So this is the initial change in the money supply. It's going to be a loan, so it's the initial loan. So we have the first loan that we made here. The first loan we made was $90. So $90 times multiplier of 10, we will get a total money supply change of $900. That's all it is. That's how the money market or money supply change works. We'll do another one. Assume a reserve rate of 25% and assume banks have no excess reserves. If Joe deposits $100 into a bank account, what is the change in the money supply? This is kind of how you'll see it on the AP test, like a word problem. There'll be bank balance sheet problems, there'll be word problems. This is how the word problem might look. If the reserve rate is 25% and banks have zero excess reserves, calculate the total change in money supply if Joe makes a $100 deposit. And I think the example is Kim. Kim deposits that the AP test actually has. The next time we do a Zoom chat, I will kind of link for you some of the practice problems and we can talk about them. Anyway, Joe deposits $100. What is the total change in the money supply? Well, it's not going to be 100 times the multiplier. And here's why. Because Joe's $100 is part of the money supply. When he deposits in the bank, it is part of the money supply. We haven't changed the supply of money. Okay? It's just gone from cash to checkable deposits. However, of that $100, the bank is going to create new loans of $75 because they have to keep 25% of this 100. So they'll keep 25. They'll loan out 75. That is a change in the money supply. That's new money. So it's this number every time. Every time now. It's this number times 1 over 0.25, which is 4. So it's going to be 75 times 4. It's going to be $300 change in the money supply. So if we went to our money market graph, this change right here would be $300. If the Federal Reserve were to drop the reserve rate from 25 to 10%, the multiplier would be 10, but it would also mean that they could loan out more of this. So look at the change. Instead of $100 being able to loan out 75, they could loan out 90 instead of 75 if the reserve ratio became 10%. They could loan out 90 of this 100, and the multiplier would be 1 over 10%, which is 10, which would be a money supply change of $900, which is a significant change. And that's why the reserve ratio is an important tool for monetary policy.